Right, so carrying on. Next week, the boat company will give out a questionnaire. The questionnaire will be given to a random sample of passengers from the first 40 passengers who board the boat. So use the following list of random numbers to select a sample of 6 passengers from these 40 passengers. So you must start with the first number in the list, explain clearly how you are using the numbers to select the sample. Okay, so this question is confusing if you haven't practiced it, but if you have practiced it, the procedure is pretty much exactly the same every time. So this is a random sampling question. So the marks are awarded here for you explicitly stating how you are using these numbers. So firstly, label passengers 01 to 40, so passenger number 1 to passenger 40. Take successive numbers to be passengers. Ignore repeats. Ignore if out of range. So for example, my range here is 01 to 40. So if I get a number like 89, for example, I ignore it. Right, so let's go through this then. So using rows, so you have to say whether you're saying rows or columns. So let's do rows. So we need to go to 6. So it's 41, which have a cross through it, 20, which is fine, 05, which is fine, 58, which doesn't work, it's out of range. Then we've got 89, which doesn't work, 45, which doesn't work, 91, which doesn't work, 11, which works, 75, which doesn't work, 39, which works. Then we've got 52, which doesn't work. We've got 86, which doesn't work. 60, which doesn't work. 20, which doesn't work because it's a repeat, so it doesn't work. 37, which works, and then 30. So those are our 6. So our passengers chosen, and I'm going to put them in order. You don't have to. Actually, I think we should put them in order, in the order that we found them. So 20, 05, 11, 39, 37, and 30. Those are the 6 passengers that we're going to choose. Let me move that down there. So the velocity time graph below shows the velocity of an aircraft for the first 20 seconds of takeoff. So calculate an estimate of the acceleration of the aircraft at the time 16 seconds. So on a velocity time graph, the acceleration is given by the gradient. So this gradient here is non-uniform. So you can see that because it's not a straight line, it's curved. So we need to approximate the gradient at this point here. So what we're going to do is we're going to use a tangent line, which touches exactly at this point here. And we're then going to approximate the gradient of this line. So there's value here. So there's 10 squares between 4 and 8. So each little box is 0.4. So this would be a 5.6. And then this height here, this is going to be 3 boxes below, 2 boxes above 60. So we have 20 and 10 boxes, so each small box is 2, so this is 64. So this triangle has a height of 64 and a x value of 56. So this is 64 divided by 56. So this, I believe, divides 8, so we get this to be 8 over 7, and we can leave it at that, 8 over 7 seconds. So calculate an estimate for the distance traveled by the aircraft during the first 20 seconds of takeoff. So to do this, we use 5 strips of equal width, convert your answer into miles, and give your answer as a decimal. So using 5 strips of equal width, so the 5 are quite clearly going to be at these marks here. So the displacement, or the distance traveled in this case, because it's GCSE, I suppose, is going to be given by the area under this curve. So we can't work it out exactly, but we can approximate. So there to there, there to there, there to there, there to there, and there to there. So similar to the last question, this isn't going to be perfect as it is an estimate, and as long as you do your method correctly, there shouldn't be any issues really. So the value here, this has a height of 4 above 0. So this is going to be 8. So this has a height of 8. And then this is obviously 4. So what we need to do is find the area of all of these and then add them up. So if I call this A, B, C, D, and E. So let's find the area of A first of all. So we know it has a height of 8. So 1/2 8 times 4. So this is going to be 16 and it's going to be meters. Let's do B. So B is a trapezium and this height here is 2 off 20. So it is 16 here. So this is going to be, and we just worked out that this one was 8. So this is going to be 1/2 16 plus 8. And then the base is 4. So this is going to be 1/2 of 24 times 4. So 1/2 of 12 times 4, which is 48 meters. Let's do C. So C is, if we go to here, this is 3 squares above 20. This is 3 squares or 4. It is 3 squares above 20. So this is 26. So again, area of this trapezium is 1/2 26 plus 16. And then the base, the height in this case, I guess, technically is 4. So that's going to be 21 times by 4. So 26 plus 16 being 42, and then half in that with this, 21. So 21 times 4 being 84 meters. Let's do D. So D being, and then this height here being 40. So this being 1/2 40 plus 26, and then the base being 4. So this is 40 plus 26 being 66, and half of that is 33. So 33 times 4, that's 120 plus 12, so that's 132 meters. And then the last one, E. So this height here is 60. So the area is 1/2 40 plus 60, and then the base is 4. So 40 plus 60 is 100, times by 1/2 is 50, so 50 times 4, equaling 200 meters. And now I believe there is some space on the other side here for us to use to write our answer. Yeah, perfect. Let me just set my camera up. Okay, so we're adding up 16, 48, 84, 132, and 200. So a little bit of work can be done here already. So this here is 64 for a start, and then 60, let's just add this up, shall we? 6 plus 8 is 14, plus 4 is 18, plus 2 is 20, so 0, 2. And then we have 1 and 4 is 5, plus 8 is 13, 6 is 16, 2 is 18, carry the 1, and then we have 480. So the distance is 480, no. So we have 480 meters, and then we have to convert this into miles. So this 480 meters would be 0.48 kilometers. And then the conversion rate from miles to kilometers is 1 mile equals 1.6 kilometers. So at the moment we have 0.48 kilometers. So I notice that this is, if you consider this in 0.16s, this is 3/10. So this is 3/10 of 1 mile. So this is going to be 0.3 miles. So the answer here is 0.3 miles. Okay, I may carry this on in the next video. Let's see what the time is. We can finish this one here, and then we'll look at this for the next one. So the aircraft carries cargo. One customer wants to use aircraft to transport a new product that is to be packaged in cuboid boxes as shown below. The boxes will meet the following conditions. The boxes will be a width of 8 and a length of 10. The length of the diagonal AB will be 14 centimeters. Calculate the height of the box. So this diagonal here is going to be 14 centimeters. So immediately a cuboid with this main diagonal here, this should scream 3D Pythagoras to most people. So this being 6 marks as well. So we apply 3D Pythagoras. So A, B, C, and then this here. So width, length, height. So we have the 8 squared plus 10 squared plus h squared, we'll call this h, is equal to 14 squared. So we have that 64 plus 100 plus h squared equals 196. So 164 plus h squared equals 196. So we then minus 164 on both sides. These cancel, so we have that h squared is equal to 196, take away 164. So that's going to be 32. So then h equals the square root of 32, which I can write as square root of 16, square root of 2, which is 4 root 2 centimeters. And that will be your answer. Let me move this up a touch. You can see it.